Okay, so today we're going to talk about the appendicular skeleton. This is going to be your appendages coming off of the axial skeleton. Um, the appendicular skeleton will include 60% of the bones in the body, or 126 in total. This will allow us to move and manipulate objects. And as I mentioned, this includes the bones of your limbs, so your arms and your legs, and the supporting bone girdles, which would be your shoulder joint and your hip joints. Looking at the appendicular skeleton here, we have what's called the pectoral girdle. The pectoral girdle will include your clavicle and your scapula, and you have one of these on either side. The good thing about the appendicular skeleton, by the way, is that you have right side and left side. So once you know one side, you know the other side. So all of these numbers, this 126 number is actually split in half. For your upper limb, your arm, you have a humerus, which is your forearm, your arm. You have the radius and ulnar in your forearm. You then have the carpal bones. There are 8 carpal bones in each hand. Then you have 5 metacarpal bones, again 5 in each hand, and then you're going to have 14 phalanges in each hand. Your thumb will have 2 phalanxes, and fingers 2 through 5 will each have 3 phalanxes. For the pelvic girdle, this is your hip joint, and this will include 2 hip bones. It's actually, the hip bones will also be made up of 3 fused bones together, which we'll see in a second. Your femur, which is your thigh bone. So that's the largest and strongest bone in the body. Your patella. In the lower leg, you have your tibia and fibula. Then you have tarsal bones, which are your ankle bones. And unlike the hand where you have 8 in each hand, you're actually going to have 7 in each foot. You'll have 5 metatarsal bones in each foot, and then same thing with 14 phalanges for your toes. Again, the big toe will have 2. Toes 2 through 5 will have for each. So the pectoral girdle connects each arm to the body. Movements will position the shoulder joints and provide a basis for arm movement. Okay. Each girdle will consist of 1 clavicle and 1 scapula, and the main purpose of those 2 bones is to really allow for all the muscle attachment for these things to occur. It also connects with the axial skeleton only at the manubrium. The clavicles, which are part of the pectoral girdle, these are S-shaped bones, and they originate at the manubrium. This is going to be at the sternal end of the clavicle, and they will articulate with the scapula, again your shoulder blade, at the acromial end of the clavicle. So here we can see this would be the sternal end of the clavicle. This would be the acromial end of the clavicle right here. This is your clavicle bone. And again, here's the clavicle. This again would be the sternal end. This would be the acromial end here. And it is an S-shaped bone. A lot of people tend to confuse these with ribs. Just remember that your ribs are going to have more of a U shape to them, or J shape, instead of this S shape. This is just looking at another view, the inferior view of the clavicle. Your scapula, or your shoulder blades, these are broad, flat triangles. They will articulate with the humerus and the clavicle. They are found on the anterior surface depression. And on that anterior surface depression, you'll find a subscapular fossa. And there's 3 sides to the scapula: the superior border, the medial border, which is going to be on the vertebral side, the vertebral column side, and then the lateral border, which would be on the axillary side, axillary being underneath your arm or armpit area. And then you have various corners or angles of the scapula. It's a triangular shape, so you're going to have 3 angles there. An important angle would be the lateral angle. This is actually going to support the glenoid cavity. The glenoid cavity is the cavity in which the head of the humerus will articulate into. Now, this isn't like this is what we call a ball and socket joint, but this particular point of attachment, it's not really like snapped in there. It's all the tendons and ligaments and musculature that's actually going to hold this in place. The joint that forms with the pectoral girdle and the humerus is referred to as the glenohumeral joint. We have a few processes on the scapula: the coracoid process, the acromion, and the spine. And again, these projections or these processes that are sort of sticking off here, the acromion, the coracoid process, and this lateral angle here, this is going to be where the glenoid cavity is formed. But these processes are very important, and this, spine here, these are very important for muscle attachments. So you're going to have muscles attached directly into the bone there. When I say muscle attachments, you actually have the connective tissue covering of the muscle is going to fuse into the periosteum of the bone, and that's what we call a tendon or a ligament. This is looking at a lateral view, so you can sort of see how the head of the humerus is going to fit right into here. And again, this is the lateral angle right here, and this is what's going to form the basis of the glenoid cavity. And this is looking at a posterior view. Now, looking at the upper limbs, you're going to have your arm. This is your shoulder to your elbow, forearms, wrist, and hands. The humerus is the only bone in the arm, and it's also referred to as the brachium. This will extend from the scapula to the elbow. The humerus will have a head. This is a rounded proximal portion that's going to articulate with the scapula. The greater tubercle, this will be a rounded projection on the lateral surface. And again, this is going to just be a point of attachment for muscles. And also, you'll have a lesser tubercle as well, okay? And those 2 tubercles are actually separated by what they call an intertubercle sulcus, or the biceptible groove. You also have what's called the anatomical neck. This marks the extent of the joint capsule, and the surgical neck, which corresponds to the metaphysis of the growing bone. Some other projections on the humerus: you have the deltoid tuberosity. This is a large, rough elevation. This will allow for attachment to the deltoid muscle, hence its name, deltoid tuberosity. The radial groove, which is found on the posterior surface, this will be a groove to accommodate the radial nerve. We also have at the distal end, the medial and lateral epicondyles. It's these structures that are actually going to start to form the elbow joints. So looking here, we can see we have the head. You can see you have your neck, okay? The surgical neck would be here. We have the deltoid tuberosity. Again, this is, you can kind of see it a little bit here, but it's a little protuberance that will be for the attachment of the deltoid muscle, okay? And then also the lesser and greater tubercle. Between these 2 points right here, you'll actually have muscle attachment. And then we have our medial and lateral epicondyles. We'll see a better view of this in a second, but this is going to be essentially the formation of your elbow joint in articulation with the radius and ulna. So here, looking at a posterior surface view, you can see the head, neck, surgical neck. Here's our deltoid. You can see how it bumps out a little bit there. The radial groove is right here. That's very difficult to see on this. And then we have our lateral and medial epicondyles there. And here you can really see this joint nicely, your elbow joint, where you're going to have the head of the radius and the coronoid process of the ulnar are going to essentially form this joint with the medial and lateral epicondyles of the excuse me, of the humerus. One thing that we will notice is on the ulna, you will see that there's a little process called the olecranon. If you could see, the humerus sort of fits in here, and you can see this little L-shaped or perpendicular formation here. What the olecranon is important for is when you extend your arm, you can only extend it out to 180 degrees. You're not going to be able to overextend that because this is actually physically blocking the ulnar from, overextending. Okay, our forearm or antebrachum. This consists of two long bones, the ulna, which is your medial bone, so in anatomical position, this would be pinky side, and the radius, which is your lateral bone, this would be thumb side. The two radius and ulnar will actually form joints at either end, the distal and proximal ends with each other, and there'll be an interosseous membrane between the two that will connect the two. As I mentioned earlier on the picture we just saw, the olecranon, this is like the proximal end of the ulnar, and this actually will articulate with the trochlear of the humerus, and this actually prevents, like I said, the elbow from overextending. Okay. All right. Other articulations of the ulnar, you have the radial notch. This will articulate with the head of the radius to form the proximal radial ulnar joint. And the head of the ulnar, this will actually attach the articular disc between the forearm and the wrist. This articulates with the radius to form the distal radial ulnar joint. Okay. Your radius, this is the lateral bone. Again, lateral bone would be thumb side. In anatomical position, you're going to have the radial tuberosity. The radial tuberosity is going to attach your biceps brachii muscle. Then you have the ulnar notch, which will articulate with the head of the ulnar, and the radial styloid process on the lateral surface. And this will help to stabilize the wrist joints. So here you can see this right here would be a radial ulnar joint, the articulation between these two bones. And down here, you also have the radial ulnar joint. The interosseous membrane is in between these two. And it's just looking at an anterior view. Okay, so in an anterior view, you can see the radius and ulnar here. And this is just showing you that olecranon. Remember, the humerus is going to fit right into here. Okay, your carpal bones. You have 8 carpal bones. There are going to be 4 proximal and 4 distal. The carpal bones are mainly cube-shaped bones, and they will allow the wrist to bend and twist. Your proximal carpal bones are the scaphoid, lunate, triquetrum, and pisiform. I would just know that, for identification purposes, you'll have to know where they are, but just know that these 4 are your proximal carpal bones. Your distal ones are the trapezium, trapezoid, capitate, and hamate. And again, just know collectively that these 4 are your distal carpal bones. So looking here, you can see we have a row of our proximal. So we have the scaphoid, the lunate, the triquetrum, and the pisiform. And then our distal ones are going to be hamate, capitate, trapezoid, and trapezium. Okay. Just looking at the anterior hand, looking at the posterior hand, they're just flipped. Okay. Your metacarpals, there are 5 long bones of the hands. They are numbered 1 through 5 from lateral to medial. They are going to articulate with the proximal phalanges. Your phalanges are your finger bones. And as I mentioned at the onset, the pollex or your thumb will have 2 phalanges or phalanxes, a proximal and a distal. And each of the additional 4 digits will have 3 phalanxes, a proximal, a middle, and a distal. And here we can see these are our metacarpal bones, the one with the Roman numerals in them. Number 1 is always going to be your thumb or your big toe in your foot. So this is 1, 2, 3, 4, 5 metacarpal of right or left hand. That's how you would identify them. Again, the thumb is going to have a proximal and distal phalanx. And again, that's 1. For fingers 2, 3, 4, and 5, you're going to have a proximal, middle, and distal phalanx. Okay. And that's it for part 1 of the appendicular skeleton, which included the pectoral girdle and the upper limb. Part 2 will be the pelvic girdle and the lower limb.